Grüß, willkommen in einem auf Regens video. Welcome to another exciting video, in this case part 20 of my Star Trek TOS timeline series of videos. In this video I'll be discussing the expansion of the Federation up until Kirk's 5-year mission. Just to remind viewers that have not seen my earlier videos, the TOS timeline is not our timeline, nor is it the TNG timeline, and it's certainly not the Enterprise series timeline. I'm only focusing on information contained in the TOS series, and if it does not conflict with other information from latter Star Trek TV series, then I may consider using that information as well. The second period in the world of Earth is the Federation period, which spans from 2161 to the time period of the TOS TV series in 2266, which is loosely the second century of human expansion in the galaxy, under the umbrella of the Federation this time. In the episode Metamorphoses, we learn what I assume I mean Federation or humans, are on 1,000 planets. This could imply the Federation consists of 1,000 planets, with some rounding-based error factor possible. Kirk states, "We're on 1,000 planets and spreading out. We cross fantastic distances and everything's alive, Cochrane. Life everywhere. We estimate there are millions of planets with intelligent life. We haven't begun to map them. Interested?" According to a Star Trek database, the size of the Federation is as follows. Founded in 2161, the United Federation of Planet is an interstellar alliance of more than 150 planetary governments spread out over 8,000 light years. The size of 8,000 light years cannot be correct, at least according to TOS. It may be accurate in the TNG timeline, where there are a lot more allied races in the Federation. However, in this case, why was the Federation based on Earth? Interesting. I suppose the League of Nations was based in Switzerland and the EU in Belgium, so it may be because Earth is not very important and the Federation is so loosely organised that it barely functions as a single political unit. On the other hand, the UN is based in what was then the most powerful country on the planet, and it's proved, no matter how many problems it may have had, significantly more successful than, let's say, the League of Nations. The other issue with 8,000 light years is to even approximately match the elements of the TOS timeline, all speeds and distances have to be 10 times greater, and inhabited planet density 1/10. If you do not ensure all these values are modified, your galactic map no longer makes sense. The number of inhabited planets cannot be reconciled, or alternatively many events could never have happened. So you need to do this times 10 or divide 10 calculation. If you do make these modifications, everything works, but then you have another issue. If warp speed can get to 10,000 times light speed, then you could cover 100,000 light years in 10 years of travel, which is from one end of the galaxy to the other. I've not studied the TNG scripts in sufficient details to provide a solution. It took me more than 3 years to study the TOS scripts, and I have little incentive to spend another 6 years doing the same with TNG. Regardless, if I was to do any additional investigation, it would be the 2 pseudo-seasons of the animated series and possibly the movies involving Captain Kirk. That would probably keep me going for another 3 years at least. So studying the TNG scripts are out of the question at the present moment. I'll have to leave that issue to someone else to think about. Let's look at a map. The blue area probably represents the territory which makes up the Federation in 2161, with some independent planets within Federation space which are involved in the Vulcan Loose Trading Association. Based on my modelling of the United Earth Federation expansion, the United Earth consists of 12 member planets, of which 8 are around 1 million each. Most of these planets would be in a sphere 20 light years in all directions from Earth. There are 62 colony planets, which each have a very low population. The larger ones are within 20 light years, but the smaller colonies are all the way out to 200 light years from Earth. The areas conquered by United Earth, or occupied by United Earth, would be free of colony planets, but I suggest the early star bases may well have been founded in these areas, which were taken from the Romulans. We need to remember the Federation is three-dimensional. Using Earth as its centre, it spans at least 400 light years in all directions, including up and down. There may be outposts beyond this border, as is implied in the Squire of Gothos, and possibly in Operation Annihilate. But this sphere is fundamentally Federation space. If we move out to 2260, this represents the Federation and Romulan border in 2260. The dark blue represents the central core of human colonisation. The light blue represents the territories in 2161, and the rest represents the current extent of the Federation. There may well be independent planets within this sphere, almost certainly there is. On the left is where I think the Vulcan Trade Association resides and its possible extent. The volume of Federation space is about 300 billion square light years, which gives us enough space for 900 planets or systems using the same density I used in 2160. This is very close to the estimate of 1,000 planets or systems in the Federation, which Kirk tells Zephyrin. The Federation may bulge out in some places, which would give us enough room for our 1,000 planets or systems. So it all seems to align. In Errant of Mercy, the Federation and Klingons go to war. As it turns out, apart from some small skirmish with the Enterprise, there is no combat as the Organians stop the war. While there was no war, we have a few clues which may allow us to position the Klingon Empire. The first point is most latter sources state the Klingons and Romulans have a border. This means the Klingons must be forward or in the rear of the Romulans, based on the galactic rotation, with a small border with the Federation. Most of the latter source maps have the Klingons in the galactic rear position. The galaxy rotates in a clockwise direction using the top-bottom orientation. If you reverse the orientation, that is, look at it from its bottom, the direction is anti-clockwise. I'm uncertain how we're actually looking at the galaxy. I'm just simply using the direction the arm trails as my guide in my maps, and that determines my top-bottom position. Based on this would be the position of the three empires at the start of the Earth-Romulan War, which explains why the Klingons were not involved. This pretty much kills my theory the Klingons were somehow involved in the war. Instead, there may have been some minor skirmishing between 2245 and 2264 between the Klingons and Romulans. This would keep them from joining together against the Federation, which is a major issue with the timeline and needs to have some kind of explanation why they didn't sort of gang up against the Federation. The key ratio I'm using in my calculation of the size of the Federation is that each inhabited planet requires an average of 320,000 square light years of space. The issue of multi-planet systems is resolved by simply ignoring it. If there is a system with 2 inhabited planets, then it simply requires doubling the space. I very loosely base this on my 2-week estimated duration of each episode, the frequency of Enterprise, that is, the frequency the Enterprise comes across in inhabited planets and the Enterprise estimated speed. If you change any of these variables, the size may well change. This density is very low. I have to assume that with warp drive, or at least fast impulse, you can be picky. The Federation was probably looking for inhabited planets which required minimal, if any, terraforming and which could grow crops on it with minimal effort. These could not be very common, thus the very low density. If you assume your best bet are stars similar to our Sun, which is a G-type star, then the density is still much too high. As you can see here, if the Federation had a radius of 400 light years, it would accommodate 1,000 planets on an average of about 320,000 square light years. This is the last line in the chart. Above that you can see the density of G-type stars within 100 light years. This value is 1/10 the value, so this means only 1 in 10 G-type stars would be selected and the other 9 would be rejected. I expect that while impulse speed was low, Earth would have focused on planets closer, even if they were not as optimal, as distance was critical in colonisation. But after the initial burst of activity and with the invention of warp, they could become very picky indeed. Thus, any colony established before 2061 could have used other stars, such as K-type, as well, but only after that, 1 in 10 G-type stars would be suitable for easy colonisation. This affects the first 10 interstellar colonies, if not a few more. This is my possible list of the 10 initial interstellar colonies in order of founding, based loosely on the distance from Earth. I found this rather surprising, and it does affect the way the Federation colonised. I originally thought most systems would have multiple planets suitable for colonisation, and that they would all be colonised. This may have made sense before 2061, but this was clearly not the case after this year. If you look Sol, we have 3 planets in the habitable zone, which implies a system can have up to 3 habitable systems. However, right now, one is a hellhole and one is marginal at best and requires a lot of terraforming. Only one planet is really available and optimal. Perhaps in the far past, Venus was habitable, but because it was too close to the Sun, and it may have been hit by something really big, it became a hellhole. At that time, Earth and Mars may have been their own particular hellhole. Then Mars may have become habitable, if cold, but quickly became a frozen desert, and after all of that, Earth became habitable. Possibly in the future, when the Sun really warms up, Mars will become really habitable and planet Earth will become a hellhole. The point is, it's rare for all the planets to be habitable in the habitable zone at the same time. They tend to flip around. As a result, even when we're dealing with a sun large enough to have multiple planets in the habitable zone, only one, if any, may be suitable at any point in time. Thus, I have to assume G-type stars may have a chance of having one habitable planet, and even here, only 1 in 10 are good habitable planets. The others, while habitable, may be still a bit too cold, hot, or have some other problem. This affects the density of habitable planets in the Federation. I have to assume before warp, all habitable planets within 20 light years will be colonised before the United Earth gets really picky. There are 21 suitable stars within 20 light years, all G or K type. This makes the inner 20 light year radius of the Federation possess a rather high density of 1 star per 1,522 square light years. The rest of the Federation space has a density of 1 star per 320,000 square light years, which is 200 times less dense. This does present some interesting dynamics. While we know that the bulk of human population will reside on Earth for a long time, no matter how aggressive Earth's colonisation is, if we look at the high density area and compare it with the rest, it would still be like comparing vacuum with lead. The population of humans within a 20 light year radius of Earth represents 99.75% of the total of all humans, with the other 380 light years radius only containing 0.25% of all the humans. I expect it would not be as bad as this, as the starbase would have been founded in the outer areas, and there would have been a focus on populating them very quickly. But even if each starbase contains 100,000 people, we still only have 0.02 billion extra people out there. This highlights the issues with colonisation in the Star Trek universe, the issue of logistics. If the Earth had huge sleeper ships which could contain 1 million colonists in sleeper pods and could travel at 1,000 times the speed of light for 3 to 6 months to its target colony planet, then take a year to unload and then another 3 to 6 months back, such a ship could transport 500,000 people per year. A fleet of 100 could transport 50 million colonists per year. In this situation, you could create huge population centres far away from Earth, but these ships do not exist in the world of Star Trek TOS. The Enterprise carries about 430 crew. Perhaps we could easily fit 500 onto it. If we assume this is a capital ship, then our modern capital ship, such as a modern CVN, has a crew of 6,000. The largest passenger liners carry about 6,000 passengers. So an Earth passenger ship would be lucky to fit 1,000 passengers on it if we use the same ratio in space as we have on the ocean on Earth today. I assume a colony ship can carry no more than 2,200 colonists. Moving hundreds of millions of colonists would take truly huge fleets, which we don't see. As it is, the minimal Federation colonist effort probably requires about 1,500 colonist ships engaged in ensuring a constant flow of colonists to the 689 colonies, which would exist in 2270. This in itself is pretty big. The question needs to be asked, why is this the case? I suspect the key factor is logistics. In the US, one person eats 905 kilograms of food per year. A lot of this is liquid, so if we dehydrate our food, we could get this down to about 100 kilos of rather boring food per year. As the British discovered in World War II, this results in people losing weight as eating becomes an unpleasant chore. You need to mix your food with some nice items which cannot be dehydrated. So 200 kilograms per person per year is probably what you need. A colony ship with 2,200 colonists and an additional 100 crew could take, at 400 times light speed, 1 year to get to the outer edge of the Federation. If we say the average is 6 months, this means each ship needs 230,000 kilograms of food. That's 230 metric tons, ignoring any packaging. I think you can see the issue. The total weight of all the people on the ship is far less than the amount of food it needs to carry, and this assumes all water is recycled. The colony ship could stop on its way to resupply, but except for the inner zone of populated colony planets, where would it resupply? All the planets have small populations which can only produce enough of food for itself and the next colony ship which would arrive with its new colonists. The colony ship only has enough food to get the ship to the colony planet, which has prepared food for the new colonists. There is little room for error, which is why the Enterprise is engaged in so many missions related to food or lack of food. Logistics is boring, but in the world of Star Trek, it's the reason why Earth seems to be the only race undertaking mass colonisation. It has little benefit to the home planet. Earth is doing it because it's paranoid and fears the type of destruction it inflicted on itself back in the 1980s and 1990s. The Romulan invasion would have caused Earth to double down on this paranoia. Other races simply lack this paranoid drive, and without it, colonisation has no other benefits. The Romulans and Klingons simply conquer other planets and garrison them with a small number of military personnel who live off the produce of their conquered planets. There's no basic logistic issues for those empires. The other issue is the logistics of the space fleet. If a ship like the Enterprise contains 6 months of food, it would need to carry at least 43,000 kilograms of food. That's 43 metric tons. Although from World War II experience, military personnel needs to eat well in order to remain at their peak. So this is probably a lot more, perhaps double. 96 metric tons of food would not represent an issue for the Enterprise to store, but it would still need to resupply each 6 months. If the Federation went to war and assembled a fleet of 12 starship plus supporting ships, it would need 200 metric tons of food per month. A starbase could not or would not have that amount of food on hand, and neither would a struggling colony of 800 colonists. So all this needs to come from a sphere centred on Sol and 20 light-years radius. This would require fleets of transport ships. A colony-sized ship craft could carry 500 metric tons of food at a stretch and with minimal crew. This could keep the fleet going for 2 months. As the old saying goes, amateurs study tactics, professionals study logistics. You may now say, well, what about matter transporters which can create food, which you see in TNG and Voyager? Let's put to one side the insanity of converting pure energy into a hamburger for lunch. This technology probably does not exist in the time of Kirk. While there is a scene from TOS episode Troubled Tribbles where food comes from a slot in the rec room, this is called a food processor in the episode. A Tribble got into it, thus it must be a device for only preparing food, not creating it. In the episode And the Children Shall Lead, a food dispenser is similarly mentioned, but this dispenses food only and no energy to hamburger conversion is occurring. In TOS, the main focus is food concentrate for a very good reason. Let's now segue into the planets that the Enterprise encountered. Let's look at the planets Kirk encountered in the first 3 episodes, which could represent 3 years of the 5-year journey. 96 Federation planets are named, which is close to 10% of the total 1,000 planets in the Federation. However, the colony planets, being less important, would have not been visited or mentioned much, so should be underrepresented. 36 member planets, or Federation member planets, are named, which is about 20% of the total of 150 in the Federation. I'll cover the actual planets in more detail in follow-on videos. While I conducted a lot of modelling in order to try and understand what is possible and what is not for this video series, I tend not to include a lot of the detail in these videos, as I suspect most would find it boring. But based on my modelling, this is a list of all the colony planets which became Federation member planets by 2266. Every planet is within 100 light-years of Earth. The methodology is reasonably simple. For the first 20 light-years, all type G, K stars are colonised. From that point on, only each 10th G-type is colonised. The star selected is simply the order the star exists in distance from Earth. This shows the 69 united Earth, 3 Martian colonies, so it totals 72 interstellar human colonies, which have developed into member planets. All planets are G-types, except those within 20 light-years, which are in bold. Most of these names are rather boring. I expect the Star Trek series would have referred to them, to something a little bit more exciting than BD plus 293190. And so with great sadness we come to an end of my part 20 of my Star Trek TOS timeline, in this case covering the expansion of the Federation until the 3rd year of Kirk's 5-year mission in 2266. This episode, or the episode scripts, can be found using the URL shown. Alle guten Dinge kommen zu einem Ende.